All right, let's turn it off and back on again, right? That always works.
Side note before we get started, if you have a question, raise your hand and I'll bring the mic over to you so that everybody can hear it. And with that, take it away.
I'm not connected. Hey, there's slides. All right, let's go. Okay, so fair warning for everybody who's here because my abstract mentioned Perses. We didn't get that far, so if you're hoping to learn about Perses, I'm sorry. But I'm going to talk about all the other stuff. And yeah, and what's your name? Eric. Come to Eric's talk, and he's going to talk about Perses. So yeah, let's talk about observability from scratch. Just real quick, an introduction. My name is Josh Lee. I currently work at Altinity. We do managed hosting and expert services for ClickHouse. Before that, I was a product manager at an observability vendor. So observability is very near and dear to my heart. So let's talk about the status quo in observability, because I talk to a lot of people about how they do observability, how they think about it, what they're doing currently. And while there are a lot of different ways to do this, invariably the answer I hear the most often from anybody who's not using a fancy vendor is Prometheus. We saw this, right? This is the Eye of Sauron in the talk this morning. It defines observability for many people. And Prometheus is great, right? I love Prometheus, but it's not the end all and be all, right? It's not the destination that we need to be at. And oh yeah, everybody's got some logs too, right? Like they're using Prometheus for their big picture monitoring, and then something goes wrong, and you have to like go in the river and like fish up that one specific log that you were looking for, roll it over, see if it was the right one. No, it wasn't. All right, let's go kubectl, pull some other logs, right? But maybe this isn't so bad. Maybe this isn't the worst starting point. If you listen to Charity Majors talking about Observability 2.0, right? Their whole thing, and I agree with it, is that there are only two signals. There's metrics, it's a number with some tags, and there's logs, hopefully structured, but not always. And that's it, right? Everything else can be boiled down to one of those two things. So I want to keep this in mind while we're talking about how we tackled observability for our database platform. So you should always start with a plan. So a quick agenda for what we're going to talk about today. We're going to talk about what our goals were setting out in our observability journey. We didn't achieve all of them, so I'm going to talk to you about how far we've gotten. And ClickHouse is a really big part of it for us because we're a vendor that offers ClickHouse services. So I'm going to talk about what it is, how it's useful for observability because it's a very useful observability data store, and then how we do observability for it because that's a completely different problem. All right, so if this is interesting, let's dive in. So our goals, pretty straightforward. We want to know that it's broken before our customers do. I think we can all agree with that. We don't want our customers complaining. Goal number one. For us in particular, we're not managing applications, we're not managing a platform. So one of the most important things is to diagnose thorny infrastructure interactions. We run our platform in a lot of diverse environments, and so there can be networking things or different interactions between the various ways of running Kubernetes, the various Kubernetes distributions and managed platforms and things like that. And that's really what our observability is focused on, is this infrastructure layer. Which is fun for me because my background's in distributed tracing, which is basically useless for this problem. And we want to validate changes and migrations, right? We're improving our platform. We're not actively developing it as much as, say, like an application with like a 2-week release cadence, but we are making changes, trying to optimize our architecture, and we want to validate that we haven't broken things when we do that. And then finally, we want to analyze our performance issues. For us, a big cost is just moving data around on a network, and so that's something that we want to get as much visibility into as we can, and I'm going to talk about how we do that. We had some secondary goals in sort of redoing our observability for version 2 of our platform. One of them was that we wanted to do a lot more dogfooding. We want to use more of our own in-house tools as part of our observability stack, and we wanted to learn how to use these tools for observability so that we could educate our customers and the broader community in how to use these tools for observability. Like I mentioned, we wanted to bring our costs under control. We move around a lot of data. It gets expensive, right? Egress is expensive, so we want to manage that. And of course, ideally, if you can achieve the same goals with fewer tools, that's always worthwhile. So this abstract was written a few months ago. We had a plan at the time. As Eisenhower reminds us, plans are not as useful as the process of making the plan. So we didn't get through all of the things that we planned. Some of the reasons, or some of the roadmaps we will overcome, and in some cases we had to adjust our plan, and we're doing something different than what we originally intended. So here's our original plan. This is kind of what we set out to do. There's a little bit missing in that first line, right, where the data goes from our tenants clusters to our object storage, because we hadn't quite figured out what we wanted to put in there. Probably we thought it was going to involve some OpenTelemetry collectors or vector, maybe another instance of ClickHouse server, right, for the ingest. So that's a part that we're still working on, and we're working on proof of concepts to see what's going to be the most cost-effective solution there. But the idea is that we're going to take the data, get it directly out of our tenants clusters, put it all into S3 object storage as Parquet files, so that our platform has access to it, and our customers have access to it, and it never has to be moved around, and it's as cheap as possible. And then to visualize the data, right, we would have this pipeline from ClickHouse to a tool called Querying, which uses ClickHouse under the hood, but translates and exposes a Prometheus-compatible API. And then we could use that Prometheus-compatible API to power embedded dashboards inside our platform using Perses. OK, so let's dive into how far we've gotten with this and sort of what we're doing. First, I want to talk about ClickHouse really quick, because this is going to be relevant to like how we're doing all of this, right? So if you haven't heard of ClickHouse, raise your hand, by the way, if you have heard of ClickHouse already. OK, so for those who haven't, it's SQL compatible. It is not transactional, right? So like don't replace your transactional database with this, but it is SQL compatible. It's massively scalable horizontally in a way that Prometheus simply isn't. And it's really, really fast at both ingestion and querying. We're talking sub-second query times and ingestion rates that you just cannot achieve with other OLTP databases. Why does that matter? Well, for telemetry especially, we're ingesting a lot of data, a lot, right? I can tell you some volumes from the platform that I used to work for. It almost never changes, right? We very rarely want to update this data. We want to write it at the time of creation. We want to be able to query it as fast as possible. And then we're only going to delete it at the end of some kind of retention period or time to live, right? So it gets written once, read a bunch, and then eventually dropped off of the end of our logs. So traditionally, if we think about like, oh, we need to be able to read this data really, really fast, we would all think about B-trees probably as like the first thing we would think of. And B-trees are awesome for reading data really fast because all of the data is already organized, right? In the format, it's all ordered by the indexes, so you can really quickly walk the tree and find the specific index for the data that you're looking for. But the problem is that the inserts are really, really costly. Inserting and updating data into a B-tree requires you to move around all of the existing data and get your data into exactly the right place, right? So it slows down and it can't keep up with the type of ingestion that we need to do in observability. ClickHouse, as a kind of an OLAP database, uses a variation on B-tree called a merge tree. And so basically what this means is that we're writing these very, very small partitions or parts in as the data flows in. So we have these small ordered parts, and then as that data sits on your disk, right, in the background, ClickHouse is optimizing it and compacting it into larger and larger parts, and this speeds up your queries. You can query the data the whole time, it's always available. But as we get farther to the right side of this graph, to the fully merged part, the queries all of a sudden, if the ordering here, if the order that we chose for our schema matches the common order by that we're using in our queries, which usually it does because it's going to be something like time and tenant, right? Then we get really, really fast queries because we're just doing sequential reads on the disk. Awesome. And we don't have to think about this, right? It just gets faster and more efficient. We just throw data at it and it handles the rest. So that's really cool. But let's talk about how this helps specifically for observability, right? So we get those fast writes. It's time friendly because, like I mentioned, if we're ordering that data by time, then at the end of our retention period, we just delete an entire partition. And that's really easy for ClickHouse to do, right? You just, whoop, gone. So cleanup is really easy, and it's really, really cost effective because each one of those partitions it's actually columnar, and so we have very compressible data inside each one of those partitions. It also comes with a bunch of great integrations. So this is kind of our starting point that we went on in our journey of like, how do we build an observability stack around ClickHouse? One of those primary integrations is the Grafana data source plugin. There are actually two. There's one that's maintained by Grafana and one that's maintained by us. It's called the Vertimedia plugin for legacy reasons. Both are great. Both can do some of the same things. The Grafana one kind of looks a little bit better, as you would expect. Ours has some nice helper functions for generating more complex queries using macros. Then we have Jaeger, which is a great tool for visualizing traces. Jaeger actually supports a ClickHouse backend out of the box, so if you don't want to use its built-in database, just say, hey, I've got a ClickHouse database for you. We've got Querying. Querying is a really cool tool, and this is actually going to be central to the new observability platform that we will be delivering. Under the hood, it uses a ClickHouse database, but on the surface, it exposes all of these really familiar APIs, also OpenTelemetry. I didn't list that there. But it exposes all of these really familiar APIs that let us get the data in from various sources and then pull it back out to all the various visualization tools, right? Loki's awesome. We don't want to ditch Loki for visualizing our logs, but we do want to replace the database so that we can control the costs of the storage. Oh, and then, sorry, I skipped a few. Kafka Table Engine, you can pump your data directly from Kafka straight into ClickHouse. And then the OpenTelemetry exporter for ClickHouse means that all of the 90+ receivers that are available in the OpenTelemetry contrib collector, you can pump all of those metrics, traces, and logs from those receivers straight into ClickHouse using the exporter. Okay, so that's really cool, right? We were talking about this middle box, storage, ClickHouse for telemetry storage. I have a whole other talk that's online that you can go check out if you want to dive into that even more. But you can kind of see, I think, at this point, why we're starting to think about wanting to dog food this for our own observability stack, because of all of these capabilities, and we want to explore this and make this available to the community. But we need the rest of this, right? We don't have the rest of these things under our umbrella at Altinity, so we need to bring in other open source tools to cover all of these things. For traditional application developers, right, you would have your application SDKs. That would probably be OpenTelemetry SDKs. You're going to have your hosted node agents. That's probably Prometheus exporters. Right, you're going to have your collection, sampling, and processing. That's going to be something like Fluent or an OpenTelemetry collector. You're going to have your analysis UI. So for us right now, that's Grafana. But of course, as I mentioned, we're kind of exploring Perses as an embedded alternative. And then you have alerting. For us right now, that's Alert Manager, which I'm sure you're all familiar with. So this is kind of the basis for us. The application SDK things, I'm going to put like a big asterisk because we're a database company. So we do that differently. And we're going to talk about that. So before I can talk about like how we do observability for our platform, just really quickly like what our platform does so you can kind of understand it in context. We're providing full lifecycle support for the databases, upgrades, backups, all that type of stuff, both in our own managed cloud, but also in our customer's cloud, right? We have a sort of like in your cloud product, which means that we need to give the customers all of the guarantees, all of the monitoring, all of the stability and reliability, but we don't have control over the environment. We just basically give them a Terraform provider, and it does its best to get things working, right? So in version 1, a big part of sort of how this all works is that the telemetry is stored alongside the compute, and in many cases, actually inside the tenant's cluster itself. And I'll show that in a little bit, like how we're kind of pulling the data directly out of the cluster to visualize it, which is really powerful. It's really great that like we have all of this data available and it's just right there. But the fact that it's stored alongside the workloads creates problems when you're trying to investigate something that happened in the past, and maybe that cluster that you're trying to diagnose doesn't exist anymore, or you don't have access to it, or right? So there's some problems with the telemetry being stored alongside the compute when it comes to disaster recovery. And then there's also just the cost associated with that, right? We have a lot of EBS volumes, and those are really expensive. So for version 2, our goal, our platform, we have achieved these first two goals, right? It's now much more lightweight and distributed. We just have very simple Go platform that you can pretty much install anywhere and run it and use it to manage ClickHouse clusters and the underlying K8s infrastructure. And the telemetry stored externally, that's the part where we're like, we ran into some road bumps there, and we're working through it. We're working through cost control and usability to kind of make this something that we could put into production, move beyond a proof of concept. So just to kind of visualize what I was talking about with our platform, right? So we have this connector component that goes in the tenant's cloud, and then it's reaching out and talking to our control plane. Not that revolutionary, right? And then here's kind of a more detailed view of what's happening inside the tenant's cluster. And now we're starting to get back to some of that observability stuff, right? We see over here we have this system namespace, and that's where we've got that co-located observability with Grafana, Loki, and Prometheus. And our goal, of course, is to keep this. We want to continue to provide this experience for our customers and for our own SREs so that they can use these tools, but we want to change the underlying storage mechanism so that it's more cost effective and so that we have better disaster recovery. So let's talk about how we do observability for ClickHouse itself, right? This is where I said there was going to be kind of an asterisk on the application SDKs. So just to level set, everyone's familiar with this definition, I'm sure. This is like the mechanical engineering definition of observability. It's our ability to understand what a system is doing purely from the outputs. We shouldn't have to like go in and change anything or do any extra work to understand what the system is doing. It should just give us enough data that we can figure it out. So it's visibility and understanding is my definition of observability. For an application, I like to talk about how like this is our basic unit of visibility into an application. And this is a request log, right? I've spent a lot of my career building REST APIs. So this is like how I think of interactions, is you've got a request log. And from this, you can actually build up all of the things that you need in order to understand the health of your application and the underlying services, right? So this is really powerful if we're talking about an application. As a starting point, you add a trace, a parent ID, right? And all of a sudden this becomes a distributed trace. You can derive metrics from this. That's a whole other talk that I also give that you can go look up. But for today, we're talking about ClickHouse. And ClickHouse is not a REST API. Well, it does have a REST API, but right, that REST request, that HTTP request is not the fundamental unit that we're thinking about anymore when we're dealing with a database. It's a query. So here's an example, just looking at a query log from ClickHouse. I want to point out the table there, right? This is a ClickHouse query, and so I'm getting the log right out of the database itself. And you can see I have just a couple of example columns there. There's a lot more information there, right? These logs include the information about the client, information about the user, information about the parts and the way that that almost megabyte of data was written, right? So there's a lot more that we can dig into, but to kind of give you a comparison to that REST request that we were looking at 2 slides ago. So this is our fundamental unit that we're dealing with now. And it comes from these system tables that are inside ClickHouse, which include our built-in metrics. We have actually built-in OpenTelemetry compatible tracing for all of the queries, just out of the box, right in ClickHouse. And then built-in logs for all of the queries, and then for also all of the background operations that are happening, those partition merges and things like that. Then we have the Altinity operator. So this is an open source project that we maintain. This is the best way to run ClickHouse in Kubernetes, in my opinion. And it also provides some additional metrics exporters so that we can look at that layer right in between ClickHouse and the Kubernetes entities that it's running on, things like the PVCs that are managed by the operator. And all of this gets delivered by way of Grafana dashboards and alert manager configs. So these are the system tables, right? So we've got, like I mentioned, we've got metrics, we've got some logs on how the merging and partitioning is happening, we've got logs on queries, and we've got our OpenTelemetry compatible trace spans, which we actually use internally when we're trying to diagnose like thorny issues. You can just write SQL queries and piece together traces from this. Here's a look at some of the exporters, right? I mentioned like the Altinity operator is adding some additional exporters for metrics at the Kubernetes layer. So this is just a diagram of some of the exporters that we're using inside our cloud manager. And then these are the ones that go inside our tenants' environments. Co-root is an interesting thing that I'm going to mention briefly towards the end. And this then, right, of course, leads to dashboards. We've got a lot of dashboards. If you take a look at the operator repo, you can see all of them. Here's an example of one of my favorites, right? So here's a dashboard that we provide to our customers inside the ACM. And the reason this is great is because they don't care, right? Like they don't care about the underlying infrastructure in the Kubernetes. They care about their queries. This is the thing that they actually have control over. And so this is where we want to surface to them where there might be things that they could optimize. Because ClickHouse, as awesome as it is and as efficient as it is, there is a bit of a learning curve. And it's very, very users very quickly sort of hit the middle of this bell curve where their queries get really, really expensive in terms of compute, right? And so you kind of need a way to manage that and see like, okay, which users, which consumers are taking up resources, and maybe we need to optimize those. So we provide a whole bunch of dashboards pulling from that information from inside ClickHouse to show our end users how their queries are performing and where their resources are going. Then we have to alert on all of that. So some of our favorite alerts, and this is a really short list, right? You might have a much, much longer list of alerts in your platform. I know we do, right? I think we have scores. But at the end of the day, these 5 are the ones that our SREs told me are the most important. If they see one of these 5, they know that they probably need to do something. And if it's any of the other ones, they can probably ignore it. So the first one and the last one, crash loop back off and Prometheus is down, it's like, okay, everything else failed. The thing is really broken. Crash loop back off is obvious. For us, Prometheus is down is a heuristic for showing that the pod looks healthy, but the ClickHouse server inside the pod is not healthy. Right? So either one of those happens, we know that something somewhere else went wrong and we need to dig deeper. Cube job failed. That one's really important for us because we're running backup jobs all the time. And so cube job failed usually means that a backup job failed, which usually means that there's some kind of connectivity problem. Same thing for cube daemon set rollout stuck. That usually means that a customer changed their configuration and the rollout got stuck because of a connectivity problem. And cube persistent volume usage, this is just us being proactive, right? We're providing databases for our customers. We don't want the persistent volumes to fill up. So we're proactive there, and we make sure that we take care of that before it becomes an issue. And then network monitoring. OK, so I mentioned that application tracing is not that interesting for us. And that's because we already have all of that information, right? Like the requests coming into our application are queries, and we already have all of the visibility into those that we need. I already showed you how we do that. So we don't need to add additional context about those requests. Really, all we need to know is what's happening at the network level, because again, those egress costs get expensive. And so this is where we're actually leveraging, rather than OpenTelemetry, we wound up going with eBPF because it gave us everything that we needed with minimal effort. So one of the things that eBPF can do, it can do a lot of things. By the way, I just learned this week that it's not an acronym anymore. It's just eBPF. So anyways, it provides, you can watch any kind of syscalls that a process makes. So that would include network requests, which means that an eBPF-based observability tool can map all of your network requests and tell you what services are talking to what other services. It can't tell you that much about, right, like the application context inside those requests, but we're a database company. We don't care. So here's an example of CoRoot. This is a tool that we're currently using heavily for network monitoring and for cost optimization, both in our cloud and in our customers' clouds. This screen that you're looking at is just, it's running on my laptop in Docker with the OpenTelemetry demo project. And I didn't like hook up the OpenTelemetry collector to CoRoot here, right? Like I just installed CoRoot, ran the OpenTelemetry demo project, and using eBPF, it traced all of the relationships. It can receive the OpenTelemetry, I just haven't provided it in this screenshot. So that's pretty cool. That's really, really powerful. This is basically something that I recommend everybody install whenever you're setting up observability, because that eBPF tracing is gonna tell you where there's a breakdown in the pipeline for your telemetry. And then querying is the other open source tool that you might not have heard of that we're using really heavily. So this is what's providing that translation layer for us between these various APIs for all of the awesome, right? Loki, Grafana, these are awesome tools. We want to keep using them. So querying is providing us with an API translation layer for that. OK, lastly, I have some community resources for you. That's a QR code for our Slack. And if you go into the Slack, I promise I will provide you links for these and other resources. We have a ClickHouse function reference. So this is a really cool thing made by one of our community members that shows you what functions you can, like what SQL functions are supported by which versions of ClickHouse. The OpenTelemetry exporter client. This is great. This is built by Justin Mason from MongoDB. And basically what this does is it allows you to really easily build SQL queries, because SQL is not PromQL, right? If you want to write SQL queries on the time series data that comes out of the ClickHouse exporter, this client, which is in Go, is going to basically provide you like a query builder interface so that you can really easily build queries in something that feels more like PromQL, and you don't have to deal with writing window functions and things like that yourself. And then the alternative DB Slack, right? If you're working on any of this stuff, if any of this talk has resonated with you, please join, please talk to me, tell me what you're up to. I really want to hear from you. Okay, so before we get to questions, just some quick conclusions. In our journey, right, we're still working on it, we're still learning, but start with what you have, right? I came in being a huge fan of distributed tracing. I was like, we need to put OpenTelemetry SDKs everywhere. We tried that, and it didn't actually help us that much. So, like, start with what you have, start with where you're at. Don't proactively guard against things that haven't broken yet, right? Just focus on the things that you know break often. Guard against axes of change. For us, the main axis of change is our customers changing their configurations, right? So that's the main thing that we need to guard against, is that they would cause some change that we need to fix. And then finally, never stop adapting, right? That list of 5 most important alerts came out of us having a weekly call with our support team and our SRE team, where we just go through all the alerts that we received that week, and it's like, hey, what did we actually do in response to this alert, and do we actually want to keep getting it? So never stop adapting. Thank you. And if you like this talk, please scan this QR code to connect with me on LinkedIn. Even if you don't want to connect with me on LinkedIn, just scan it to let my boss know that you like this talk. Thank you.
We have a couple minutes left. Are there any questions?
Thank you. That's a great talk. I did have a question about just earlier on, probably a slide somewhere between 5 and 10. You had a question. You showed how with a worm, I guess with a merge tree, that you guys have this process of taking the raw data coming in and then refining it until it's like at this fully optimized for queries part.
Yep.
And I guess I was just curious, how long does that process take from the time it comes in until it's fully all merged together? Is that like a minute? Is that like a day? Is that like a few weeks? I'm just curious.
It's on the order of minutes, right? Okay. So it's going to depend on the volume of data, but on the order of minutes.
I have 2 questions. Loki, that's integrated. I mean, but I'm assuming that's an open source project.
Yep.
That you're contributing to heavily or not, or what?
We're not contributing too heavily to Loki. We maintain
that's Grafana, right?
The Grafana plugin. That's where a lot of our work goes, and that's one of the reasons why we haven't moved so quickly to Perses, is because we want to keep dogfooding that plugin that we maintain.
Okay, I see. And the eBBF functionality, that's, you showed it on the screen.
Yep.
That's I think it's the second to last slide.
Yeah, co-root.
Yeah, so that's co-root. Yeah, so you recommend that as far as a simple, quick and dirty way to integrate eBBF.
Yeah.
Looks pretty cool. I hadn't heard of it. Okay.
Yeah, so co-root has an agent. If you install the agent and the backend, it's pretty lightweight. And yeah, like, it's great.
That goes through OpenTelemetry, or where do you integrate?
It supports OpenTelemetry, but out of the box, it's just using eBPF. And so it's using eBPF to create this graph, and then you can enrich, it basically has an OTLP endpoint that you can send OpenTelemetry to, and it'll combine.
Cool, okay, thank you.
We got time for one more if anybody wants to ask a question.
So I've seen that you have used ClickHouse. So why not Elasticsearch?
Why not Elasticsearch? Well, because we're a ClickHouse services company. So for us, it's that ability to store things, right? Like Elasticsearch is great, but it's a very, the vector database format, right? To me, I think vector databases really should be more for an index, and you want your raw data to be if you're dealing with data at the scale that observability vendors or like massive observability operations are, I think ClickHouse is just easier to work with and more efficient and cost effective. And then you can, from that raw data, right, calculate your vectors if you need really efficient search. But ClickHouse, right, one reason I would have used Elasticsearch in the past would have been for the efficient full text search. ClickHouse has that, right? It has token filter indexes, movement filter indexes. So you can do all of that, and you can still have all of the relational stuff that you like with SQL. Yeah.
Perfect.
All right, thanks. Let me just take a picture real quick.